Okay, let's talk a little bit about multiplying radical expressions. Multiplying radical expressions is similar to multiplying monomial algebraic expressions. So this is important. Let x be greater than or equal to 0. It's important here. So in monomials, if I had 2x times 3x, I'd multiply coefficients and multiply variables to get 6x squared. Well, with radical expressions, I multiply coefficients and multiply radicals. Then I have, this would end up being 6 times square root of x squared, which is x. Now, theoretically, you should write that as 6 absolute value of x. But that's why I said let x be greater than or equal to 0 is important. Because since they said that x has to be greater than or equal to 0, you don't need the absolute value because x can't be negative anyway. Okay? But if they didn't specify that, then x could be positive or negative, and you would need the absolute value on that one. Okay? All right. You can also apply the distributive property to radical expressions. So let's simplify this one. 3 square root 2 times 2 square root 6. Multiply coefficients, multiply radicals. You get 6 square root 12. 12 has a perfect square factor of 4, so you could think of 12 as 4 times 3. Square root of 4 is 2, so that's how they got 6 times 2 square roots of 3, which gives you 12 square root 3. How about this one? 3 square roots of 5 times 2 square roots of 5 plus 5 square roots of 3. Notice these are in parentheses. So you use the distributive property and distribute the 3 square root of 5 to each term. Okay? And then this one, multiply the 3 and the 2, which will give you 6, and square root of 5 and square root of 5, which will give you square root of 25. Here, multiply the 3 and the 5, and the square root of 5 and the square root of 3. You have 6 square root of 25 plus 15 square root of 15. Square root of 25 is just 5. So you end up with 30 plus 15 square root 15. And the 15 under the radical has no perfect square factors, so you just leave it as square root 15. Okay, here's a couple for you to try. Go ahead and pause the video. All right, 3a. Here's what I like to do. I like to multiply the coefficients. So 7 times 2 is 14. 6 times 3 is 18. Then I know that 18 has a perfect square factor of 9. So it's 9 times 2. So that gives me 14 times 3 square roots of 2. So that gives you 42 square roots of 2. Okay? Number 3b, 9 times 11 is 99. And 5 times 15 is 75. 75 is 25 times 3. So that's the perfect square factor. So you'd have 99 times 5 square root of 3. So that'd be 495 square root of 3. Now you could do 5 times 99 in your head really quick. Let me just take a second to explain this. 99 is really close to 100, right? It's 1 off. Well, if you did 5 times 100, boom, 500. That's simple, right? Well, if you're doing 5 times 99, it's like 5 times 100, but you were off by 1 each of those times, so you'd be off by 5, right? So you just do 500 minus 5, right? It's really like thinking of it as 5 times 100 minus 1, and then you get 500 minus 5, which gives you 495. Anyway, 3c, got to distribute. All right, so you get 12 square root of 6 plus 18 square root of 4. Square root of 6 has no perfect square factors. 4 is, square root of 4 is 2, so it's 12 square root of 6 plus 36. Okay? All right, and the last one, distribute. So you'd have 15 square root of 6 minus 5 square root of 9. So 15 square root of 6. 6 has no perfect square factors. 9, the square root is 3. So it becomes 5 times 3. So 15 square root 6 minus 15. All righty, daddy. All right. Okay, so you can also multiply radical expressions with more than one term in each factor. This is similar to multiplying two algebraic binomials with variables, so you just FOIL. So let's find the area of this rectangle. So this side is 5 square root of 2 minus square root of 3. This side is square root of 5 plus 4 square roots of 3. When I multiply those, I would have the quantity 5 square root of 2 minus square root of 3 times the quantity square root of 5 plus 4 square root of 3. Well, in order to multiply those correctly, you have to FOIL it all out. Okay? So the first terms, you would multiply this 5 square roots of 2 times square root of 5, which gives you 5 square roots of 10. The outer, 5 square root of 2 times 4 square roots of 3, which gives you 20 square roots of 6. The inners, negative square root of 3 times negative times positive square root of 5 gives you minus square root of 15. And then the last will give you negative square root of 4, or negative 4 square root of 9. Blah. Okay, 10 has no perfect square factors, so it's fully simplified. Neither does 6, neither does 15. But 9 does. Square root of 9 is 3 times the 4 gives you 12. And that's, let me back up a step. And that's our final answer for that one. Okay? Now, that looks weird, but if you plugged all that into a calculator correctly, you'd actually get a number, and that number would represent the area of that rectangle. Okay? All right, here's our last practice problem. Go ahead and read it carefully because they give you the formula and describe to you how to do it. Okay? Pause the video. Okay, we're back. The area of a rhombus can be found by using the equation area equals 1/2 d1 times d2, where d1 and d2 are the lengths of the diagonals. What is the area of the rhombus at the right? Well, I'd have to do 1/2 times 8 square root 5 minus 3 square root 6 times 6 square root 5 minus 2 square root 3. Okay, let's begin to FOIL this. So 6 times 8. I'm going to leave the half out here for now. 6 times 8 is 48 square roots of 25 minus 16 square roots of 15 minus 18 square roots of 30 plus 6 square roots of 6 times 3 is 18. Okay, so that would be 1/2 48 times 5 minus 16 square root 15. 30 has no perfect square factors. 18 can be thought of as 9 times 2. Square root of 9 is 3, multiplies the 6, gives you 18 square root 2. Okay? So this would be 1/2 240 minus 16 square root 15 minus 18 square root 30 plus 18 square root 2. Okay, none of the radicals have the same radicand, so you can't combine any of them. Now I would distribute the 2 to everything and get 120 minus 8 square root 15 minus 9 square root 30 plus 9 square root 2. Okay? And again, if you plug that all into your calculator and got the decimal number, that would just represent the area of that rhombus. But this is the answer we're looking for. All right, guys. Last little thing here is just a summary of the operations. Now, this is on page 637 in the book, if you want to see it, and it just talks about how to add, subtract, and multiply radicals. All right? So that's it for this section, guys. Please continue on to your assignment, and as always, reach out if you need any help. Take care and have a great day.